We will go through the slides for chapter 7, and we will talk about the normal probability distribution. One more time, this is a continuous random variable. A continuous random variable has an infinite number of possible values. So the normal distribution is a continuous probability distribution for a random variable x. It is the most important continuous probability distribution and has the bell-shaped curve. The mean, the median and the mode are the same, are equal. It is a bell-shaped graph. The total area is equal to 1, 0.5 to the right side of the mean and 0.5 to the left side of the mean. So the normal curve approaches but never touches the x-axis. It goes to plus infinity and negative infinity. This is one example for the means and the standard deviation of the normal distribution. The mean gives the location of the line of symmetry and the standard deviation describes the spread of the data. So the standard normal distribution is a special case of the normal distribution with a mean of 0 and a standard deviation of 1. So we have to calculate the z-score. The z-score is x minus mu over sigma. Sigma is the standard deviation, mu is the population mean. So in this case we make a transformation by using the z-score. We have a mu, the mean, we have the standard deviation. So for the standard normal distribution it's a special case with a standard deviation of 1 and mu equal to 0. So let's go to see some different examples. So when you look for the probability between 0 and z or between 0 and negative z, simply you check the z value in the table and this is the probability. So let's go to see example number 1. What is the probability z to be between 0 and 1.5? In this case we can check the chart. So we have to go for 1.5. If you check for 1.5, this is going to be the probability 0.4332. 0.4332. So if you check from 0 to z or z to negative z, simply you check the table and this is going to be the answer. Second case is when you have a tail, and by tail we mean the end of the normal distribution. Could be a right tail, could be a left tail. So in this case simply you check the table and then whatever you get you subtract from 0.5. So what is the probability z to be greater than 2.25? So again we have to check the table of the normal distribution. So for 2.25 the probability will be 0.4878. But because we have a tail, you look for greater than 2.25, we have to subtract by 0.5. So the answer is 0.0122. So this is the value from the chart, and then we have a tail, so we subtract from 0.5. Same case, what is the probability z to be less than negative 1.75? So we have a tail again, so we have to check the probability on the chart for 1.75. So for 1.75 the probability is 0.4599, and then we have to subtract also by 0.5. So the answer, as you can see, will be 0.0401. Then if we have the area between two z values and the mean is inside the area, in this case you have between two negative z-scores or two positive z-scores, then you have to calculate both probabilities and subtract the smallest probability from the largest. So what is the probability z to be between negative 2 and negative 1? So you have to calculate between negative 2 and 0, negative 1 and 0, and then subtract the two probabilities. So we have to go back to the table. So for negative 2 the probability is 0.4772, for -1 it's 0.3413. So you subtract 0.4772 minus 0.3413, and in this case the answer is going to be 0.1359. If you have between two z-values and the mean is inside the area, then you calculate the two probabilities and then you add the two probabilities. So be very careful with the between. If the mean is inside the area, you add the two probabilities. If the mean is not inside the area, you subtract the smallest probability from the largest. So in this case, between -0.8 and 1.4, we have to check again the table. So the first probability is 0.2881, the second is 0.4192, so we add the two probabilities. So the answer is 0.7073. Now let's go to see an example now that the z-score is not given. So for this problem, we know the mu is 2.4. We know the standard deviation is 0.5, and then what is the probability less than 2 years before upgrading? So x would be less than 2. So in this case, what we have to do first of all, we have to calculate the z-score. So the z-score is -0.8. This is 2 from the x, this is the mu 2.4, and this is the standard deviation. So for -0.8 we check the chart, and the answer is 0.2881. But then it says less than 2. So in this case, less than -0.8. So what you have to do is that you have to subtract the probability 0.2881 from 0.5. So the answer is 0.2119. Next example, the mean is 45, the standard deviation is 12, and then you look between 24 and 54. The mean is inside the area. So in this case we have to calculate two z-scores between 24 and 45, and then between 45 and 54. So the first z-score is -1.75, the second is +0.75. So we figure out the probabilities, and then the mean is inside the area, so we add the two probabilities, and this is going to be the answer, 0.7333. And the third example, which is based on the previous one, so that means mu is 45 and the standard deviation is 12, more than 39 minutes. So we calculate the z-score, which is 39 minus 45 over 12. This is -0.5. We check the table, the probability is 0.1915, and then this area is 0.5. So we have to add 0.5. One more time, the area to the right side of the mean is 0.5, and the area to the left side of the mean is 0.5. So the answer is 0.6915.